All right, we are going to take a look at example 5. Find equidistant points from sides of an angle. We've got a question here. We're actually going to come back to that. I'm going to show you guys a visual of this conveyor belt. So here it is.
An airport has an automated system to direct bags toward the correct terminal. A baggage inspector is assigned to watch the point where the conveyor belt splits to make sure the system doesn't make any mistakes. To minimize the amount of time it takes to retrieve a misdirected bag, he needs to stand equidistant from the two conveyor belts. He knows that the distance between a point and a line is the length of the line segment from the point that is perpendicular to the line. The inspector finds that the first place he stood was too close to the conveyor on his left, so he moves closer to the one on his right. He notices that when he's standing about the same distance from either conveyor, the 2 points he's measuring to are about the same distance along each conveyor belt. So, to find another place to stand, the inspector picks 2 other points the same distance along the conveyors and finds the intersection of the lines perpendicular to the conveyor belts at those points. He notices that the points equidistant from the 2 belts appear to be collinear, and the line through them appears to bisect the angle formed by the conveyor belts. The baggage inspector marks the angle bisector with a line of tape on the floor, reasoning that as long as he stands over the tape, he will be equidistant from the 2 conveyor belts.
Okay, so back to the question that we're being asked, now that we kind of see what the situation is. It says, consider the 2 triangles that result from drawing a segment from the point on the angle bisector where the inspector stands to each conveyor belt, forming a right angle with that conveyor belt. How are the triangles related? So I'm going to go back to the picture. This one's just a little bit bigger from our video. Here's a triangle, and here is a triangle. And our question is, how are these 2 triangles related? Well, I can see that we have a congruent angle to a congruent angle here. We have this right angle, which is congruent to this angle. And we also have this side congruent to this side. They are both 6 feet. So by angle, angle in a non-included side, angle, angle, side, we have 2 congruent triangles.